Hello, I'm Manuel. I'm a researcher here at Microsoft Research, and I'm going to tell you about the GUARD project. The GUARD project is about making the world a safer place by protecting programs written in C and C++. Every day we hear about cyber attacks, about machines being hacked, attacks that steal money or information from people and organizations, and GUARD is about preventing that. We are more and more dependent on computers. We run computers everywhere to do all kinds of things. Governments have lots of computers. We have personal computers. Our electricity supply depends on computers. Our water supply depends on computers. And so it's really critical that we make these computer systems secure. And right now they are vulnerable. Computers were not that fast when these languages were designed, at least compared to our computers now. So it was incredibly important to be efficient and to write efficient code. So, security was not that big of concern at the time because, computers were not connected to each other, there was no internet, it was a completely different world.
So there's an awful lot of code that's written in these very powerful languages like C and C++, but unfortunately these languages make it very easy to write bugs in the code, and there's an awful lot of code that was written at the time when systems are not necessarily connected to the internet, and so now you've got these rather old, fragile bits of code being connected to networks where there's all these nasty bits of code, malware out there, attempting to break into these systems.
Why do we have Windows updates? Well, it's because it's extremely difficult to make everything totally flawless all of the time. Okay, even very high quality diamonds have flaws in, right? When you look with a microscope, there's a kind of an arms race where Microsoft and other software companies and researchers try and develop new methods of securing computer systems, and organized crime and other malevolence are continually trying to find better ways of breaking in. So there's a kind of an arms race.
So the issue is that we have lots of programs that have vulnerabilities. They have low-level defects that can be exploited by attackers to gain control of the programs. And that's where GUARD can help.
Well, what's going on under the hood is that one of the things that an attacker normally tries to do is to find something which is called a control flow transfer, so where the program is executing in one place and then it's going to start going and executing somewhere else. The change from A to B is a change that's potentially it can be controlled by the attacker because they've sent you some particular malformed rubbish, for example. And they might trick you to go, instead of going from A to B, to go from A to C. So what's going on under the hood is that at compile time we analyze the program and we find all of the places where it's hard to identify at compilation time exactly where the program might be going next. And so what we do is we insert at the point where it actually makes a transfer from A to somewhere, we can't quite tell where. It could be many good places. Maybe it's also a bad place if the attacker has managed to do something bad. And we insert a check there to make sure that it's going to one of a large set of possible good places.
When the program is running, if we see the program deviating from the correct behavior, we immediately stop the program. So we don't allow an attacker to gain control of the program.
The extra safety checks are added at compile time, so when you take the source code, it's the same source code, it's not changed in any way, but those extra safety checks are added by the new feature that we've added to the C compiler. And so what that means is by making a small number of changes to the C compiler, we can then take all of the existing code and recompile it to add the extra safety. So it's a way of getting a very broad coverage of extra safety checks without needing to modify a huge amount of code.
We've partnered with this MSEC organization, which is part of the Trustworthy Computing division inside Microsoft, which is this division responsible for defining security policy for the whole company. And we also partnered with the server and tools division inside Microsoft, in particular the tools organization. These are the groups that are responsible for the development tools.
Putting together this sort of system requires both changes to the NT kernel that need to be done by the kernel team, as well as changes to the compiler that are done by the compiler team, as well as changes to the linker and the loader, which are done by both the people in the compiler team and also people in the kernel team. So to get the whole story to line up, we need to have everybody agreed about what we're going to be doing across lots of different groups within Microsoft.
We have many different types of attacks. We don't have that many root causes of the problem. So with Guard, we attacked a significant fraction of the root causes. So we think it's broadly applicable and it can prevent many of these attacks.
And so finding the sweet spot, which is how do you actually improve security in a way that doesn't reduce the performance cost to the end user and doesn't increase the engineering cost to the developer. How do you combine all of those aspects? So what we've achieved with the Guard technology is a way of doing that, something which measurably, significantly increases the difficulty of attacking the computer system, and at the same time provides only very minimal performance cost and almost no engineering cost.
There's no question, this is a very powerful technique which will make whole classes of exploits completely irrelevant, and with one fell swoop the bar has been raised massively for all attackers out there, and it will improve the lives of millions of people.